morning, everyone. Welcome to this webinar on planning for the emergence of electric aviation at airports. Before we start the webinar, just a bit of housekeeping. You should see somewhere on your screen a GoToWebinar control panel, and there you have two important windows. The first one is chat, where you can ask all your questions all along the session, and we will address them at the end of the webinar. And the other one is handout, where you can download a copy of this presentation material. Okay. I am Gael Lebris, a senior aviation planner and engineer with the WSP based in Raleigh, North Carolina. And today we're going to talk about the advent of electric aviation and how we can prepare our airports and aviation systems for these emerging users. We're going to start with a quick refresh or basic information on what is an electric aircraft. We're going to talk about the timeline of the emergence of electric aviation. We're going to talk about the potential impact on the aviation demand and then on the aviation facilities, especially how we can provide for these emerging users with these new aviation fuels or energy vectors, talk about power supply requirements, couple of slides about policy considerations, and then it will be time for your questions. So what is an electric aircraft, or what are electric aircraft, since there is some diversity within electric aviation? Basically, an electric aircraft, also known as e-aircraft, they have part of or all of their propulsion system that is powered by electricity, either stored into batteries, or you can generate on board that electricity through fuel cells that are going to process hydrogen. And electric aircraft, typically they might enable a greener and quieter aviation with lower operating cost, making air mobility more accessible and socially acceptable. And you see on the right part of the screen all the different use cases for this electric aircraft, from general aviation to larger regional aircraft for regional air mobility. You might have heard about advanced air mobility. So advanced air mobility, or AAM, it's a broader concept that includes urban and regional air mobility. It's not necessarily specific to electric aviation, even so we expect these two modes to use advanced aviation technologies that include electric aircraft. And the idea between AAM is that with these advanced aerial vehicles, we are going to provide a safer and more aviation transportation system that can use aviation facilities, nearby communities, within a dense urban environment, and provide point-to-point air services for passengers and cargo, again, within urban and suburban areas, as well as between cities and maybe more remote communities. So UAM and RAM are part of advanced air mobility, which is, again, a broader concept that is not necessarily specific to electric aircraft, but will use electric aircraft for providing point-to-point connections. You might have heard about VTOL, STOL, CTOL. So just to maybe clarify these terms, when we talk about VTOL, it's vertical takeoff and landing. You will have, actually you have, since helicopters technically are VTOL vehicles, but in the near future, you will have also electric VTOLs or eVTOLs operating from heliports / vertiports. Some of them might be actually hybrid, taking off and landing vertically, and then flying with horizontal, propellers with tilt rotors, and typically we'll have 2 to 6 passengers in these vehicles, providing, again, point-to-point connections from dense urban environment. And then you have the STOL, short takeoff and landing. Interestingly, there is not a kind of consensus around the definition of STOL. Sometimes you find that these are aircraft or facilities with a runway shorter than 1,500 meters. You might have read also 800 meters. I even saw 1,500 feet. Well, the idea behind is that you have a constrained aviation facility with an extremely short runway and most likely a takeoff or approach path that is steeper than the practice, you know. And here you're going to have maybe a slightly larger aircraft, 6 to 60 passengers, from urban areas to a wide variety of facilities. And then CTOL, conventional takeoff and landing. These are your typical airport where you have typical runway longer than 1,500 meter, and approach and takeoff path that have a regular slope. Okay. And this is, again, another way to consider electric aviation. And this time we look at the different performance function of the range and the payload or passengers from small UAS to larger aircraft, including eVTOLs, air taxis, small commuter, regional aircraft, and long endurance UAVs used by the military, but also private providers that could, you know, for instance, broadcast internet services, etc., through this high altitude, long endurance vehicles. And what's interesting to see is that, again, electric aircraft are on the horizon. They are coming. And you see on the screen that for most of the market segments, they're already flying prototypes or concepts that are becoming very mature, such as the Heart Aerospace ES-19 for regional aircraft and other ones. Now, the big question is, what about a larger aircraft? And as of today, with the existing technologies, we are not able to fly all electric larger aircraft. But again, with today's technology, and you know that the aerospace hybrid electric technologies, they are progressing very quickly. So it might not be a surprise if within the 10 or 20 coming years, we develop, again, propulsion technologies able to fly larger aircraft. Either they are all electric or a combination of electric and conventional or thermal propulsion systems. And when I said that electric aircraft are on the horizon, the industry and the regulators, they start to be aware of that timeline, and starts to fund studies and exploratory efforts for thinking all we can, not only have aerospace technologies able to fly electric aircraft, but all we can accommodate these vehicles at airports and aviation systems. Because of course, the technology is great, but it's not only about flying an aircraft. It's also about having a whole ecosystem around that aircraft and being able to fit them in at airports and aviation systems. And when I say fit them in, it's not only from a technical or geometrical standpoint, but we are talking also about policies and so on. So you see, for instance, Washington State in the United States released its first electric aircraft implementation study earlier this year. Colorado is doing a similar effort. I am leading for the Transportation Research Board a comprehensive study. We will talk a bit more about that later, which will be the first ever guidance and toolkit for facilitating the accommodation of electric aircraft at airports. And you see that on the other side of the pond in Europe, the Nordic Council of Ministers creating a pretty ambitious initiative for facilitating the emergence of electric aviation. Avinor, which is a large airport operator in Norway, is also researching a lot on that matter. And you see also another initiative in the United Kingdom. And this is just, of course, a selection of ongoing programs and initiatives. So in terms of timeline, the first generation of smaller aircraft, 2 to 12 seaters, many of them being retrofitted with batteries and an electric powertrain, they might be certified as soon as next year. And then when we talk about larger regional aircraft, that might be powered by hydrogen through fuel cells, they might follow at the 2025 horizons. And then you will have a period where you're going to have air carriers acquiring these technologies and flying them. And of course, this is going to take a bit of time before we can see electric aircraft replacing their thermal counterpart. So they might become more widespread between 2030 and 2040. And what's interesting is that based on a market assessment that we did as part of the study for the Transportation Research Board, we might have about 2% of the US fleet of aircraft being electric by 2035, assuming that electric aviation can deliver everything that is promising, including lower operating cost, a quiet flight, and greener flight, of course. And then again, there is some uncertainty and challenges about powering larger electric aircraft with electricity. But at the 2040 horizon, we should have at least what we need for flying larger aircraft with a hybrid system, meaning that for takeoff and landing, you might assist your propulsion system with thermal engines like turboprops or conventional jet engines powered with Jet A1. And then for the cruise, you might rely only on electric engines, which is going to tremendously reduce the emissions of these aircraft. So that's a possible scenario to electric aviation. And so what about the impact of these emerging users on the aviation demand? Again, assuming that we have lower operating costs, capital expenditures, we could see an increase of the air demand since airfares might be lower. And you will see as soon as these electric aircraft are commercially available and certified for air carriers, to see point-to-point air services operating by small regional air carriers. And similarly to what we can see in many parts of the world, and for instance, the northeast of the United States, you have Cape Air operating these small Cessnas 402 from small airfields to small airfields or larger facilities such as Boston Logan or St. Louis, for instance. And we will need to accommodate that diversity of aircraft at commercial service airports and also adapt smaller airports to provide for these aircraft. And some general aviation facilities that today have airfield capacity that is underutilized, they might become actually local transportation hubs for communities and see their capacity may be better utilized, providing both general aviation recreational facilities, but also being, again, transportation hubs for point-to-point connections with small electric aircraft. What's interesting for your situational awareness is that this concept was explored in the early 2000s by NASA and the FAA in the United States through the Small Aircraft Transportation System research project that was aiming to, well, exactly that actually, facilitating the emergence of that kind of regional air mobility system. And at the time, it didn't happen because the technology was not yet ready. We were not talking about electric aircraft for providing these services and other reasons. But again, I mean, it's interesting to see that finally, with the progress of technology, we are able to make that kind of micro mobility, micro air mobility happening. One of the challenges for accommodating these aircraft is, of course, the emerging aviation fuels associated with electric aircraft. And when I say fuel, another term to say so, it's energy vector, because of course electricity is not a fuel per se, but let's say emerging aviation fuels. And either your electric aircraft are powered by batteries or fuel cells converting hydrogen into electricity. So we might have to develop a logistic and a supply chain for providing aviation hydrogen at airports, and also equipping aprons and stands with electric chargers. And to do so, you have different technological solutions, the second table on your screen, which is kind of similar actually to what you see today with the jet fuel, right? You can have fixed airport units, electric chargers, or a hydrogen system for hydrogen. You can have mobile units, or, and that might be actually something kind of new in aviation, we could swap the container that has the energy inside. So either you are going to swap batteries at the gate, or you're going to swap hydrogen containers, and the goal of that is to minimize the impact on the turnaround time. Now, the difficulty with the swapping is that it will depend a lot on the analysis and the final decision of the national aviation authorities. Is that swap a minor or major alteration to the aircraft? If they decide that it's a major alteration, it means that it cannot be performed by a ground handler. It has to be performed by a licensed mechanics in a certain way, and the aircraft has to be verified afterward. So it might kind of adversely impact the business case for swapping. So we will see what the national aviation authorities will decide about swapping. About batteries, again, we can have fixed chargers at the gate, and these fixed chargers, they can be above the ground, like you see today with electric ground service equipment, for instance. Or if we want to preserve, multiple parking configuration, what we call MARS as well, and prevent obstacles on the air side to provide more flexibility, they could be into hatches, under the ground. And that's not new in aviation, because today for the 400 hertz, you already find this kind of technologies, hatch into the ground for, again, minimizing the footprint of the technology on the gate itself. One big issue with electricity becoming an aviation fuel, of course, it's the resilience. We cannot afford to have power outages, and one of the questions is how we can increase resilience of the power supply at the airport, including backup solutions in case there is an outage from the main grid. Also, solutions I mentioned a moment ago: battery swap and mobile chargers, which means that respectively you have either an inventory of batteries and or mobile chargers that is typically, a supercharger on a truck with a very powerful battery, or again a system of fuel cell with hydrogen. And here we have a depiction of the potential logistic for supplying hydrogen to aircraft, electric aircraft, powered not by batteries, but by fuel cells. So again, converting hydrogen into electricity. So you have two kind of main solutions here. It's either you bring container full of gaseous hydrogen and you swap them at the gate, or you're going to use trucks, kind of conventional trucks that are going to fuel the aircraft with hydrogen, kind of like we do today with JT1. One way or another, of course, the big question is how do we supply the airport or the hydrogen fueler with quote unquote aviation hydrogen? How can we develop an aviation specific supply chain of hydrogen? And maybe very short term, one way to go around is to use this system of container swapping, where you don't need pipelines and so on. You can transport containers full of hydrogen to the airport and do the swapping and bring them back to the warehouse of the providers. That might be a solution to address at least the short-term demand. And the longer-term demand, actually, the hydrogen infrastructure, the development of the hydrogen infrastructure might be facilitated by the emergence of the hydrogen economy. You might have heard about that. We have a lot of different potential users of hydrogen. It's not only in aviation, not to list all of them, but electric vehicles, some of them at least might run on hydrogen, and other urban applications. So we'll see what happens in the future. And about power supply requirements, so here we are assuming we are only considering electric aircraft powered by batteries. These are the typical power requirements, just rough order of magnitude, depending on the type of aircraft and the type of mission. And you see that when you have to charge simultaneously 5, 10, 20 aircraft, and that's not an unusual situation at airports, of course, you reach very quickly some 500s of kilowatt or even megawatts, and that's not that's doable at, I would say, most of the airports. But it's not only about having the the connection to the grid. It's also about bringing the power on the air side, at the gate, and so on. And still, you will have pretty large amount of airports, especially remote facilities. They might need actually to consider upgrading their power supply to reach these power levels. So here we of course we have a topic about power supply and also power resilience, because again, if we turn electricity into an aviation fuel, we need to make sure that the supply is resilient. And then when we consider the power supply requirement issue, we have also to consider what we call the electrification of everything. It's not only the aircraft that is going to ask for more electricity, it will be also the airside vehicles, the landside vehicles, passengers coming with their personal car. Oh, it's an EV, electric vehicle, so they have to recharge when they are at the parking garage. And then the terminal facilities are getting more electric, and so on and so on. So when you consider refitting, upgrading your connection to the grid or your power supply system, you will have to consider all these different electricity users that we have to account for, of course. And one way to do that is, of course, to as part of your master planning effort or separately, is to do a utilities master plan to consider local power generation if needed, and that include what we call microgrid, which is about producing electricity at the airport, or all or at least part of the needs in electricity. I'm not going to read that slide. It's just to show you that there are a lot of policy considerations to be addressed in order to facilitate the emergence of electric aviation. And it's not only about aviation standards and regulations. And one question of it, for instance, is, do we consider vertiports as airside or landside, or should they be regulated, certified? Should we impose an SMS to these facilities? What about stall ports? Are they general aviation or commercial services? Or can we categorize them? But it's also about everything about electric aircraft. You bring something new on the table. How can we facilitate the emergence of these systems and account for them into regulations, policies, and laws? And one of these emerging issues, for instance, is the overlap between the way we regulate utilities and the way we regulate aviation and aviation fuels. And for instance, here in the United States, many states, you cannot, as a facility owner, impose a surcharge, an additional charge on the kilowatt hour that you are selling to your final user. So that's the question. How do you get money? How do you cover for the capital expenditure and operating expenses of your electric charging infrastructures for aircraft, for instance, if the local law doesn't allow you to use that process, to pay for the facility and the expenses. And here we have a lot of education to do to our local, national, and regional lawmakers and regulators, because again, these issues are not necessarily known today. We are just at the beginning of the journey in electric aviation. So it's important to voice our concerns as an industry and to talk to all the different stakeholders of electric aviation, and that includes, again, the regulators and the policy makers / lawmakers. In conclusion, well, electric aircraft are coming. Some already fly, and again, the timeline is very tight. We might see the first small commuter aircraft certified for transporting passengers as soon as next year. We might see regional e-aircraft being certified as soon as 2025, and maybe sooner than we expect, we might see larger aircraft, hybrid or fully electric, flying as well. So it's time for us as individual airports and as an industry to consider all these issues, to address them as a group, as an industry, and to develop guidance, standards, recommendations, and funding mechanisms when appropriate in order to facilitate the accommodation of these new users. And just to let you know, again, we have this ongoing transport research project with the US Transportation Research Board, electric aircraft on the horizon, an airport planning perspective. We should be releasing the research report in late summer 2021, early fall 2021, and the report comes with a toolkit with an airport electric demand assessment tool in order to plan for the long-term increase of your electricity demand and see how you can address it. And last but not the least, we just released at the end of last week a WSP paper on greening future flight. It's not only about electric aviation, we talk also about hydrogen and sustainable aviation fuels, and you will find a link to the paper into the presentation material that you can download from the control panel of the webinar. And here we are. I'm sorry if I was not able to address all of your questions. Again, it's a very broad topic. I've been working on these issues for many years now, and we only have about 20 minutes to talk about all of these. But if you have any questions, if you like to talk further about your projects of integrating electric aircraft at your airport or aviation system, please feel free to reach out to me by email. And now it's time for your questions. So Sharon, do we have questions from the attendees?
Yes, we do. Thank you, Gail, for your presentation. So again, just a quick message, you can log your questions in the question box on the GoToWebinar platform. And we have quite a lot from people who registered. Thank you for entering those. We'll start with the first one. What is the impact on airport electrical power demand at airport peak operation, for example, busy hours?
Yeah, that's a very good question. And that reminds me this slide that I showed. Here we are, when we talk about power requirements. And these are just, again, some rough order of magnitude based on ongoing aircraft programs, depending on the size or category of aircraft. And you see again that very quickly, if you assume that 5 to 10 aircraft are going to charge at the same time, well, you might be around between 500 kilowatt to 5-6 megawatt of power demand. And again, I mean, it's doable. And at many airports, it might not require to upgrade your connection to the grid, but you might give some thought about that and do some utility planning, you know, and make sure that you can get the right power level at the edge of the airport property, and then bring that power to the airside and have the right systems for in terms of power management, in terms of electric chargers and so on. Maybe you might want to consider, you know, if you don't want to upgrade your power system to share power between the different airside users. You know, you already have that today on the airside between electric ground support equipment and jet bridges, for instance. You know, it's something very common when you bring electric GSE chargers on an existing apron to piggyback actually the power supply on these of the jet bridge. You know, and when the jet bridge is not operative, the GSE are charging. When you need the jet bridge, the chargers are off and the jet bridge is prioritized. That's one of many solutions in order to address at least the short-term power supply issue. And just a reminder, in the tool that will be available in this TRB research report and toolkit, you will find an airport electricity demand assessment tool that is quite comprehensive and take into consideration not only the needs of aircraft, but also of EGSC, other airside vehicles, landside vehicles, terminals, and so on. So that will help you as well to get maybe a more precise or detailed understanding of your long-term power demand for your individual airports. And again, please feel free to reach out to me if you need, if you have more questions on the issue.
Thank you. The next question is saying, as you mentioned, the electrification of airside is the key. What would happen with diesel-powered equipment? How will this transition be dealt with?
Sorry, I didn't hear the second part of the question.
What would happen with diesel-powered equipment? How will this transition be dealt with when you speak about electrification of airside?
Yeah, well, I will say, there is a lot of analogy here with what happened with electric ground support equipment, EGSE. Again, from one day to another, well, we brought electric vehicles on the air side, and we had to charge them. I will say electric aircraft is a bit the same. Maybe they have more higher power or energy demand, but it's a bit the same. So we have to first get an understanding of the needs. How many aircraft are we talking about? Are we talking about a commercial service aircraft with short turnaround times, or we might need some kind of supercharger here? Or do we have aircraft maybe for recreational use or for training purpose, and we can manage the recharge, differently, and maybe, have some kind of smart power management approach in order to lower the the load, the demand, on your power supply system. It will be really a case by case, depending on your local users, the level of activity, and their operational requirements. So it's why it's very important at the local level to discuss with your stakeholders, maybe have a small task force, and then depending on the involvement, depending the country where you are, the state, the DOTs, the federal level might be able to help you as well to understand your demand, but also to fund part of the investment into the charging infrastructure. Even if so, today, and wherever you are, most of the funding mechanisms, even for green energy at airports, are not necessarily taking into consideration electric aircraft. Electric aircraft charging systems are 99% of the time not eligible as of today to these mechanisms.
Thank you. We'll take the last question. Will hydrogen at airports introduce new safety hazards?
Last but definitely not the least, that's a very good question, because hydrogen is a completely new fuel at airports, a completely new gas at most airports. And we will have to come up with, like anytime we introduce something new on the airfield and the airport in general, we will have to do our homework in terms of a safety management system and safety risk assessment, figure out what are these new hazards. And it's not necessarily about aircraft hazards per se, on that matter. Of course, OEMs, manufacturers, they know to do that. They already done a tremendous job in terms of safety assessment with themselves and as part of industry organizations such as SAE International and so on. But then the airport segment of that issue today is not yet covered. And in our research report for the ACRP, for the Transportation Research Board, we did a fairly comprehensive safety review. Okay, it's not a safety risk assessment, but a safety review identifying these airport-specific hazards, and try to come up with some elements of discussions, for helping individual airports conducting their local safety risk assessment. And typically, you might find, hey, you have a hydrogen aircraft. In case the aircraft crashes, is it generating additional hazards for the passengers, for the firefighters, and so on? Or, hey, you are transporting containers of hydrogen on the airfield. If you have a collision between that whatever trailer or truck with another GAC or an aircraft, is this bringing new hazards? And of course, when OEMs are designing hydrogen tanks and so on, they have to take that into consideration, and as far as practicable by design, make them robust to this kind of low energy collision. About crash is something different. Of course, this is high energy collision, but at least the low energy occurrences, such as an aircraft runway excursion within the runway strip, of course, or the RSA in the US, or a collision during taxiing, or between a GSE and a truck with hydrogen containers. Well, it's my opinion that these containers should be resistant to this kind of safety occurrences.
Thank you. Gail, if you
Any other
can move to
questions?
the last slide again. We have many more.
Sorry.
Unfortunately, we don't have time to review them today. All these emails will be answered directly by Gail by email. So we are at the end of our webinar session. Thank you for your time and thank you for joining us today. Please feel free to follow up directly with Gail for any additional questions. And I would like to thank all attendees for joining today. Thank you very much.
Thank you, everyone. Fly safe and stay safe.
Thank you.